Today, I want to go over conditionals and control structures. And at the end of today, we're going to add one more control structure called a for loop. All right, this is going to be sort of a review of Chapter 3 conditional statements that we've done, so I'm going to go through it somewhat quickly. It's very important that you understand the different conditional statements, control and conditional statements, because we're putting a lot of coding tools in your tool bag, and you have to know which to use and when to use it. Okay, so a conditional statement allows you to make a decision and change the flow of control. It's how you ask a question in coding. All right, the basic if statement. This is a single decision. You know, as you go along, the flow of control is top down. When it reaches your if statement, it will look at the Boolean expression, whether it's primitive data types that are being compared to a sentinel or some other like a string being checked at is equals, equals, ignore case to a yes or no, something. So if it hits that, it will, and it's true, if this statement is true, the very next statement, it will execute. Otherwise, it will skip over that statement and execute whatever code is below like it never existed. Now you can have a body. A body is when you have more than one line of code and you have to encapsulate the body with open and close squiggle brackets. Now remember, an if statement happens once. So once it passes this question, it never revisits that question. All right. So now the if-else. An if-else statement is not a single question. When you use an if-else, it's going to either do one thing or it's going to do the other thing. So if this if statement, this Boolean expression is true, it will execute what's exactly directly underneath it and then skip over the else. But if this Boolean expression is false, it skips over this executable code and goes down to the else, and it'll do whatever you put under the else. You can do the same thing with bodies by adding squiggle brackets when you have more than one line of code. All right, the if-else if statement is built to do multiple decisions, kind of like a menu, kind of multiple ors. Is this true, or is this true, or is this true, or so on down. So same thing, if this one's true, it automatically does that. Else, it goes to the next one, checks if that's true. Else, goes to the next one, see if that's true. Else, it goes to the next one. You use this already in the grades program. Average grades. Okay? Average grades. Now you can also put these lines of executable code, if they happen to be more than one line, in curly brackets. Same thing. All right? The nested if statement. A nested if statement is when you have an if statement inside an if statement. Now this nested if statement cannot be reached. You can't get to it unless this Boolean statement is true. If this Boolean statement is true, then this Boolean statement is asked, and this might be reached. If this Boolean statement is false, it will go to the else. You can also just have an if statement nested inside an if statement. Now, if this Boolean statement, the first Boolean statement, is false, it doesn't even reach this if else. This is not reachable. If this is false, it'll skip down to the else and do whatever code you put in the else. Now let's do loops. So far we learned a couple loops. We learned the while loop. We learned the do while loop. And today we're going to learn the for loop. The while loop repeats itself over and over and over. As the code reaches this Boolean expression, if this Boolean expression is true, it will do everything that you have in the body of the while loop. However, a while loop does not guarantee that the body of your while loop is ever reached, because if this Boolean expression is false, it does not enter the while loop. It will skip below and continue on with the program. So a while loop doesn't guarantee that the body is ever reached once. But once it does get reached, it will keep running until its Boolean expression becomes false. Okay, so now the do the while loop. A do while loop does guarantee that the body is reached at least once. It's guaranteed at least once. And then at the end, it checks to see if the Boolean expression is true. If the Boolean expression is true, then it will run again and keep on running until this Boolean expression becomes false. Once this Boolean expression becomes false, it exits the do while and it continues down in the program with other lines of code. What's kind of weird is it has a semicolon at the end of the while loop, which we're not used to, but in this case it has one, so be careful about that. Now what we're going to do is we're going to talk about the features of a for loop. A for loop is used most often when the number of loops is known. So a finite number. I'm going to run this loop 10 times. I'm going to run it 20 times. A while loop, in comparison, is used when the number of loops is unknown. A while loop is best used when you use a sentinel, or you keep asking the user, do you want to do it again? Do you want to enter another number? Do you want to enter another grade? And you get a yes or no answer. And based on that yes or no answer, you run the while loop again and again and again. But a for loop is more like you have a database that you want to add up all the numbers, and you know there's 60 numbers, so you do it 60 times. A for loop and a while loop are functionally the same, because you can make a for loop do exactly the same thing a while loop. Like you could ask for a sentinel, and the sentinel gets put into the for loop as how many times it's run, so it acts like a while loop. Both loops can use a sentinel value, like I talked about before. All right, let's look at the structure of the header of a for loop. It has three parts. It has the initial starting index, which is a local variable. It only exists within the for loop. You declare it in the for loop, and you initialize it in the for loop. You have a Boolean expression. Usually it's an inequality, whether it's less than or equal to, greater than equal to, all right? And you have an increment or a decrement, all right? You can go backwards. You have to watch out for infinite for loops. If I were to eliminate the index, that means the index would never grow. And because it never grew, it'll stay at 0, and if it stays at 0, 0 is always less than 10, and the for loop will run forever. You do not want an infinite for loop. A for loop provides a lot of flexibility because you can determine where you want to start, where you want to end. You can determine whether you want to go forwards or backwards using an increment, plus plus, or decrement. You can even traverse through a for loop doing every other one, or every third one, or every fourth one. You could do a plus equal 2, plus equal 3, etc. Whatever you want to do. You want to look at every fifth one, it would be plus equal 5. So you have a lot of flexibility with a for loop. All right, so look, how many times will a for loop run? This is a typical AP question, and you have to make sure you know how to do it. All right, so in a for loop, you always start somewhere. You have the index where you're going to start, whatever number this is. A typical starting point is index 0 at the beginning element. And you have an end, because if you don't have an end, it'll be infinite and you'll never get out of the for loop. So it's going to do it until it reaches this end. So once end, because end, let's say end was 10. Is 10 less than 10? No, so it kicks out. So to figure out how many times you run it, you do end minus start. That's how many times it'll run. Now, if the for loop is a less than or equal to, you have to add 1 to that number. All right? Add 1 to that number. Now, there are also nested for loops that we're going to get into more often. This is like for loop runs one at a time, but when it reaches the inside for loop, this thing will completely cycle all the way through 6 times, because 6 minus 0 is 6. So this will run 6 times, and then it'll increment outside 1 more, and then it'll go inside and run 6 times again. So this thing runs 6 times 5. This thing will run 30 times. Consider this more like the hour hand, and consider this the minute hand. The hour hand only clicks over once after all 60 minutes have gone by, and then it clicks over 1, and then the 60 minutes happen again. All right. So an analog clock is a good analogy for a nested for loop. So now what we're going to do is we're going to have a JGrasp example. This video and the PDF that you have of this is a good summary of all our conditional and control structures.